Now, let's continue with simultaneous equations. Now, this is a different category of simultaneous equation that you will get in the exam. Notice that it's worth 6 marks. So let's practice some questions like these and see what it is that we are dealing with. So throughout this question, the use of a calculator is not permitted. So you can still use a calculator to check your answer, okay? But you cannot use your calculator to solve the entire question, okay? So it's like the examiner will have no clue whether you've used a calculator or not. If you're using it smartly, that is only to check your answer. So the complex numbers z and w satisfy the equation z is equals to 1 plus z plus 1 plus iota times w is equals to iota, and 1 minus iota times z plus iw is equals to 1. So how do we do this? Let's see. Well, first of all, we can make, how can we use it smartly? Okay, we'll talk about that. We'll talk about how you can use your calculators over here, not today, but later on. So, and the calculator part is only a fraction of the part, okay? But we will talk about it, don't worry. So first of all, let's see what variable it is, whether it's z or w that I can make the subject, okay? So let's say that I make w the subject, okay? And there are no right or wrong answers to this, by the way, but it would be easier for us to make w the subject if I am using the first equation, okay? If I'm using the first equation, let's make w the subject. And once again, no right or wrong answers. If let's say you end up making z the subject, that's perfectly all right. You'll still end up with the correct answer. It's like you're solving two equations simultaneously, which is in fact what you're doing. So w is equals to, first of all, iota minus w. So iota minus z. Oops, sorry. This is 1 plus iota times w, which is equal to iota minus z. And then if we make w the subject, so that's going to be iota minus z over 1 plus iota. Okay. So think of it as the third equation, which we're going to plug in the second equation. Okay. So we're going to plug this in the second equation, which means 1 minus iota as it is times z as it is plus iota multiplied by w, which means iota minus z, okay, divided by 1 plus iota, which is equal to what? Which is equal to 1. Okay, now remember, you have to solve for z and for w. So throughout this process, focus on somehow isolating z. And when you've done that, we have to give the answer in this form. So that means if it's in fraction form, so we have to then rationalize it. Okay, rationalize it, or basically get rid of the complex part from the denominator. So let's expand this. So if I expand this, so we have z minus iota z plus iota square minus iota times z over 1 plus iota, which is equal to what? Which is equal to 1. Now, next step is that we are going to take the LCM. Now, I just realized that if we don't expand it, okay, let's leave the expansion part for the next step. Why? Because you'll notice why expanding it later on is actually a good idea. So if I take the LCM, which is going to be 1 plus iota, so we have to multiply this by 1 plus iota. Now, multiplying this by 1 plus iota means that we can use the third identity. Now, let's say if you did expand it and you didn't realize that you can use the third identity, that's still all right. You can still expand and do it the normal way. Plus iota square, which by the way is minus 1. Okay, so plus minus 1, and then minus iota times z, which is equal to 1 as it is. Okay, now let's see what's next. So 1 minus iota into 1 plus iota, we can use the identity over here. And whenever you have some expressions like these, it's best that you expand them on the side. So 1 minus iota into 1 plus iota, we saw that when you're dealing with complex numbers, a minus b iota into a plus b iota results in a square plus b square. So this is going to be 1 square plus 1 square. Okay. So this is equal to what? This is equal to 2. And what's b? B is basically the coefficient of the complex part. Now, so we have z times 2 minus 1 minus I z, which is equal to, if we cross multiply, we have 1 plus iota. Now let's see where we are now. So we have 2z minus iz, which is equal to, if I take one across the equals to sign, so 1 plus 1 is 2. Okay, let's write it as 2 directly, plus iota. Now, the benefit of doing that, the benefit of keeping z on one side and everything else on the other, is that we can take z common. So we have z times 2 minus iota, which is equal to 2 plus iota. And now we have z, which is equal to 2 plus iota over 2 minus iota. But can we leave our answer like this? Can we leave our answer like this? No, we cannot, because the question says that we're supposed to give an answer in this form, which is x plus iota times y, which means now we have to rationalize it, but that's the easy part. We multiply this by 2 plus iota, and we multiply this also by 2 plus iota. As far as the denominator goes, we know exactly what happens to the denominator. The denominator becomes 2 square plus 1 square. As far as the numerator is concerned, you can use the identity. So that's going to be a square plus 2ab, which means 2 times iota, plus b square, which means plus iota squared. Now, iota square will be minus 1. 4 minus 1 is 3. So that's 3 plus 4 iota divided by 2 square, which is 4. 4 plus 1, which is 5. Now, don't leave your answer like this. Instead, write it as 3 upon 5 plus 4 upon 5 iota. Okay, and what's this? This is basically the value of z. Okay, remember, it's a 6-mark question, and we have just found out the value of z. We still have to find out the value of w, but nothing to worry about. That's the easy part. Finding out the value of w is now the easy part. So here we are. Let me know if you have any questions so far. If not, then let's move on. Okay, great. Now, how do we find out the value of w? Let's go back. So if we go back and we plug it in, where do we plug it in? We plug it in here. Okay, so let's continue working from here. Don't worry, you'll have plenty of space for this question, okay? So the question is, what version of z do we use? Do we use the a plus b iota form, or do we use the 2 plus iota over 2 minus iota form? Well, the answer is it doesn't matter, because in the end, you will have to rationalize it anyway. So w is equals to iota minus 2 plus iota over 2 minus iota divided by 1 plus iota. So we'll break it down and we'll solve it separately. First, we're going to focus on the numerator. So as far as the numerator is concerned, we'll have to multiply this by 2 minus iota, which means that the LCM of the numerator only is going to be 2 minus iota. So we'll have 2 iota minus iota square minus 2 plus iota. Okay. And this is being divided by 1 plus iota. Don't forget that. Now, iota square is minus 1. Minus minus 1 becomes plus 1. And we have 1 minus 2, which is equal to negative 1. Okay, so I'm skipping a few steps here. So this is what we have. 2 iota minus iota. That's simply iota. Minus iota square, which becomes minus minus 1, which is plus 1. And 1 minus 2 becomes minus 1. Divided by 2 minus iota. And this will be multiplied now by 1 upon 1 plus iota. Okay. So you have to earn every single mark over here. Okay. You don't take this for granted. You have to earn every single mark over here. So as far as the numerator is concerned, we'll just rewrite it as 1 minus iota. As far as the denominator is concerned, there's a decent amount of working to be done. 2 into 1 is 2. 2 into iota is positive 2 iota. Minus 1 into iota is minus iota squared. So we have 1 minus iota over, now again, iota square is minus 1, minus minus 1 becomes plus 1, and 2 plus 1 becomes 3. So this becomes 3 plus iota. Now what do we have to do? We have to then find out, this remember is what? This remember is the value of w that we're finding out. Now what we have to do is we have to find out the value of, we have to rationalize it and give it in the form of a plus b iota. Okay, so let's do that. Let me make sure that I've done everything correctly. Yeah, everything seems, yeah, everything looks good so far. So what do we multiply it with? We multiply it by 3 minus iota, and we multiply this also by 3 minus iota. Why does iota minus 1 into 1 becomes 1 minus iota? Oh yeah, that's a good thing that you pointed out. I was supposed to write it as minus 1 plus iota. Okay, let's do that again. So let me check from the beginning. So that's 1 minus 2, that's minus 1. So yeah, 2 iota minus iota is equal to, you're right. Okay. So this will be minus 1 plus iota. And then the denominator will be 2 square minus minus 1, that's 3. 3 plus iota and minus 1 plus iota. Okay. So what do we multiply it with? We multiply it by 3 minus iota, and we multiply the denominator also by 3 minus iota. Okay. Now let's work out the numerator first. So the numerator is going to be 3 squared plus 1 squared. Now, as far as the numerator goes, minus 1 into 3, that's minus 3. Minus 1 into minus iota, that's plus iota. And iota into 3, that is plus 3 iota. And then minus iota squared. Okay. Now the denominator becomes 10. So here's the denominator. Minus 3 minus minus 1. So that becomes minus 3 plus 1, which is equal to minus 2, and then plus 4 iota. Now this is something that can be further simplified. So let's do that. So if I simplify it further, here's what we get. We get minus 2 upon 10 plus 4 upon 10 iota. And the final answer is minus 1 upon 5 plus 2 upon 5 iota. This is the value of W. Now, as always, take a good look at it. Let me know if you have any questions. So why don't we solve it like we would solve two equations simultaneously? Isn't that what I did? Isn't that exactly what I did? I solved it like two simultaneous equations. What kya kiya maine? The unknowns here are, yeah, I did it by substitution only. See, what are the unknowns over here? The unknowns are W and Z. Okay. And because these are complex numbers, these unknowns will be expressed in the form of A plus B iota. So I made W the subject, substituted it into the other equation. Now, elimination is not possible here. Elimination is not possible. If I expand it, no. I mean, if you're lucky, if you get a question where elimination is possible, that's a different scenario. But in this particular question, no, it's not possible. Okay, so these are, I mean, don't get me wrong, these are difficult questions, okay? These are not easy questions. These are difficult questions where there's a lot of working, and you have to make sure that you check as you go along. Like Luna pointed out a mistake. If I hadn't fixed it, then, the rest of the answer would have been wrong. So here's another question. Once again, notice that it's worth 5 marks. Let's see what it says. Throughout this question, the use of a calculator is not permitted. All right. Now, the complex number u and v satisfy the equation. U is equals to u plus 2v is equals to 2i, and I u plus v is equals to 3. So once again, let's first decide what it is that we're going to make the subject. So if you're using the first equation, it would be easier if you make u the subject. That way you won't be dealing with any fractions, although at some point you will have to. It's unavoidable. But if you're using the second equation, we can make u the subject, which is going to be 3 minus iu. Okay, so because this has come with the help of the second equation, we're going to substitute it in the first equation. So u plus 2, in place of v, it's going to be 3 minus iu, which is equal to 2 iota. Now, u plus 2 times 3, and once again, the answer that we're supposed to give is supposed to be an x plus iy form. So 2 times 3 is 6 minus 2 u iota, or you can write u in the end, doesn't matter how you write it, it's multiplication at the end of the day. So let's write it as 2 iota u, which is equal to 2 iota. Now let's keep u's on one side. So u minus 2 iota u is equals to minus 6 plus 2 iota. Let's take u common. So we have 1 minus 2 iota, which is equal to minus 6 plus 2 iota. Let's make u the subject, which is equal to minus 6 plus 2 iota over 1 minus 2 iota. Okay. Now we can't leave our answer in this form, so we rationalize. We multiply this by 1 plus 2 iota. Not rationalized actually. Okay, but it's similar to rationalization. So here's what we do. In the denominator, it becomes 1 square plus 2 square. So that's pretty straightforward. It's the numerator where you have to do the working. So minus 6 into 1, that's minus 6. Minus 6 into 2 iota is minus 12 iota. Plus 2 iota. Plus 4 iota squared. So when rationalizing, we will always use 1 minus 2 iota and not. If you're using minus 2 iota plus 1, for example, if you've written it that way, then you multiply it by minus 2 minus 1. So it's just the sign in between that has to change. The order doesn't matter. How did you know what to make the subject as we have many variables? Okay, how many variables do we have, Fatma? How many variables do we have? In both these equations, 2. That's correct. So of the 2, what do? We make any one the subject, right? So if I was using the first equation, I would have preferred to make u the subject. And if I'm using the second equation, I would prefer to make v the subject. That way, I don't end up dealing with any fractions. It's like, so it's like you're solving two equations simultaneously, two regular equations. The difference is that now you're dealing with complex numbers. That's the difference. So the same rules that we apply to solving two equations simultaneously apply here as well. Whether you make x the subject or y the subject, where you can avoid fraction, we try and do that. Where we can't, so be it. We'll deal with a fraction. So kya hua? ठीक है? Does that answer your question? And so I don't understand the part you have solved with red. Okay. Now, can I leave the answer in this form, Fatma? Notice that the question is saying that give both the answers in this form. No, we can't. So how do we divide two complex numbers? Let's go back. How do we divide two complex numbers? What do? How do we divide two complex numbers in such a way that the denominator is no more a complex number? We multiply it by the conjugate. Okay. Remember, we multiplied by the conjugate. Conjugate हमने कहीं पे लिखा होगा ना? हाँ. ठीक है. So if you're doing this, so what you have to do is you have to multiply the numerator and the denominator by the conjugate of the denominator, which means you change the sign in between. Okay, makes sense? All right, now let's resume. That's what I've done in red. Okay, that's the red part you're talking about. So iota squared is -1. Okay, 4 into -1 becomes -4, and -6 minus 4 becomes -10. And -12 plus 2 becomes -10 iota once again. In the denominator, what do we have? We have 4 plus 1, which is 5. Now remember, this is u that we're solving for. So we can divide both terms by 5. So we have -2 iota. I've skipped a step over here. This is the answer. Now, this is just the value of u. We still have to find out the value of v. Now, thankfully, because v is not in fraction form, and u is also not in fraction form, okay, the benefit here is, now I will prefer, because this is where you have to make some decisions. Here, which form of u would you prefer to plug in here? Would you prefer this form or the final form? The fraction form or the final form? The fraction or non-fraction? Yeah, non-fraction. Why? Because if I plug in fraction, which is fine, I can do it. I'll still get the right answer. But we can see that if we plug in fraction, we'll be dealing with a fraction, which means we then have to go through the process of dividing it and writing it as x plus iy. But if I plug in the non-fraction form, that means I will get my answer straight away without having to divide it or anything. So v is equals to 3 plus 2 iota plus 2 iota squared. Now 2 iota squared will be -2 and 3 minus 2 will be 1, and we have 1 plus 2 iota as the final answer. Okay, so there you go. Take a good look at it. Let me know if you have any questions. If you don't, then let's move on and talk about quadratic equations in detail. When you have ignored the, when you have used the identity, why have you ignored the, okay, it's called iota, just so you know, it's called iota. I mean, how is that mathematically correct? Okay, I'm not ignoring anything. Okay, I'm not ignoring anything. It's just that It's just that we're using a shortcut. Okay, I'm not ignoring anything. It's just that we are using a shortcut. मैंने कहीं लिखा भी होगा. Yeah. Okay, it becomes a standard rule, and that's what we use. We're not ignoring anything. We're not bending the rules or anything. It's just that whenever you do a plus b iota into a minus b iota, what happens is it's still a square minus b square. But then when you expand b square, it becomes b square into minus 1, which then eventually becomes positive b square. Okay, so देखो, this is what's going on in the background. I explained this in the last class as well. A square minus b iota, the whole thing squared. Now there's nothing we're going to do with a square, but this is going to be b square, iota square. What's iota squared? That's minus 1. So once again, I'm not ignoring anything. This is what it simplifies to. So what does this become? It becomes a square plus b square. Okay, so instead of doing the working, this is what we do directly. ठीक है फातिमा, अब ये याद रखना है आपने, ये नहीं कि हर दफ़ा. No, no, you don't have to show this in the exam. You can just straight away write a square plus b square. Okay, this is now, you can say, a different version of the third identity when you have complex numbers. ठीक है, all good. अब भूलना मत इसको. Now let's talk about quadratic equations. Okay, now I know you're probably thinking that what's there to talk about? You guys already know what quadratic equations are, but now the difference is that we're going to talk about quadratic equations with complex roots. So let's say we solve an equation. Let's say the question is that we solve x square plus 4x plus 5 equals to 0. So we use the quadratic formula. We can't do middle term breaking over here. You're very welcome to try though. So minus 4 plus minus square root of b square minus 4ac. I'll just write it directly. So that's going to be 16. 16 minus 20. So that's going to be minus 4 divided by 2a. So that's going to be 2. Now, there are no real roots, but there are, however, imaginary roots. And that's what we're going to write down. Now that we know how to deal with imaginary numbers or complex numbers, that we, as we call them, so we're going to write them down. So let's find out one solution with positive and let's find out the other solution with negative. Now, if you think about it, the solution that we get with positive will be minus 4 plus 2 iota divided by 2, which will be simplified to minus 2 plus iota. And the solution that we get with negative will be minus 4 minus 2 iota. So what's the only difference? We saw this in the last class also, but now we're looking at it in detail. The difference is that it's only the sign of the square root that changes, which means it's only the sign of the coefficient of iota that changes. So no matter what quadratic equation you're solving, if the roots are complex, then the roots will be in such a pattern that one would be a plus b iota and the other would be a minus b iota. So you'll have two roots and one would be a root and the other would be its conjugate. Okay, so let's write that down. Note. And we wrote this down earlier as well, but I want to emphasize on it because in the last class we didn't emphasize on it a lot. So if z is one complex root, if z is one complex root of a quadratic or even a cubic equation, this applies to a cubic equation as well. Why? Because you get one root of a cubic equation by doing trial and error. The other two roots that you get is by solving a quadratic equation. So even a cubic equation boils down to a quadratic equation. So if z is one complex root of a quadratic or a cubic equation, the other would be the other complex root. The other complex root will be z star, which means z conjugate. Okay. So if z is equals to a plus b iota is one root, then z star, which is equal to a minus b iota, would be the other root. Okay, and that's a standard rule. You're very welcome to try it with any other a quadratic equation, and you'll notice this to be the case. Okay. Now, so what we did here was we solved a quadratic equation. Okay, we solved a quadratic equation. But in the exam, sometimes you will be given the roots of a quadratic, not a quadratic, it's usually cubic. You will be given the roots of a cubic equation, and you will be asked to go back to the cubic equation. Okay, you'll be asked to go back to the cubic equation. So that's what we're going to learn right now. We're going to learn how to find how to find the quadratic equation. So we're going to learn how we do finding the quadratic equation. And same concept applies to cubic equation as well. Okay, so let's say the question is that find the quadratic equation, okay, with roots -2 plus and minus iota. Okay, -2 plus and minus iota. Now, before I do this, let's take a step back. Okay, let's go back to O levels or maybe AS. Now, if let's say you solve this equation, x squared minus 5x plus 6 equals to 0. Now we can do middle term breaking over here. Okay, this is a quadratic equation which will give you real roots. So once you solve this, I'm just going to write down the answer directly. You will get x equals to 3 and x equals to 2. Now, what if I ask you to go back to the quadratic equation? What are you going to do? Question for you guys. If I ask you to go back to the quadratic equation, what are you going to do now? If let's say I give you the roots, okay, I just give you the roots and I don't give you the equation which you can see above. Plug in the values. No, you won't plug in the values. This is what you're going to do. You're going to do x minus 3. Okay, x minus 3 into x minus 2 equals to 0. And this way, when you expand, you will go back to the quadratic equation, which is x squared minus 5x plus 6 equals to 0. Okay, good job. Now, there is another way. Alternatively, here's what you can do. And this is the method that you will notice we will use often. If any quadratic equation can be written in this form. So we have x squared minus the sum of roots into x plus the product of roots. Okay, roots का क्या मतलब है? Roots का मतलब है the solutions. X squared minus sum of roots into x plus the product of roots equals to 0. Okay, now notice how this works, and this works like a charm. So x squared, okay, minus, this minus sign stays as it is. Sum of roots. What are the roots? 3 and 2. So that means their sum would be 3 plus 2. Don't forget to put an x outside the bracket, plus the product of roots, which means 3 into 2 equals to 0. And notice the equation that we get in the end. We get x squared minus 5x plus 6 equals to 0. We get the exact same equation. Okay, so long story short, the alternative method is this. Let's rewrite it. The alternative method is that you have x squared. Now, how does this work? We're going to talk about that some other day. X squared minus sum of roots into x plus the product of roots. Okay, this is the magic formula that we are, this is to save time in the exam. Okay, this is the formula that we are now going to be heavily relying on. So let's say we have to go back to the quadratic. We already know what the quadratic equation is. Okay, so the reason why I've already written what the quadratic equation is so that we can check whether our answer is correct or not. So we have to go back to the quadratic equation, which has complex roots 2 plus minus iota. So here's method 1. Okay, here is method 1. Now method 1 is that x is equals to -2 plus minus iota, which means one root would be x equals to -2 plus iota, and the other would be x equals to -2 minus iota. So just like what we did, obviously that's what the answer is going to be, because Actually, it's going to be x squared plus 4x plus 5 because it's the same quadratic equation that we solved earlier. We're going back to using the roots. Okay. So method 1 is basically this method right here. Okay, where we multiply. So this would become x minus 2 minus iota into x plus 2 minus iota equals to 0. Okay, koi baat nahi. So if we expand this, this should take us back to the quadratic equation. But here's the thing, when expanding this, do it smartly. Okay, and what's that? What identity can you identify over here? Take a closer look and tell me, what identity do you see fitting over here? Algebraic identity. Let me specify. That is correct. A plus B into A minus B. Now the question is, what's A and what's B? Well, we can disagree, but at the end of the day, we will get the same answer. Okay, we can disagree about what we take as A and what we take as B, but at the end of the day, we will get the same answer. So the obvious A and B are basically x minus 2 is A and iota is B. Okay, so here, if I want to use the third identity, so x minus 2 is A and iota is B. Sorry, ulta keh diya. X is A and 2 minus iota is B. Okay, we can always rearrange it, write it as x minus iota minus 2 and x minus iota plus 2. But as of now, x is A and 2 minus iota is B. So this is A minus B into A plus B. Okay, so this way we'll save some time and we won't have to individually multiply every single term. So let's apply the identity over here and let's see what do we get. So we get x square minus 2 minus iota, the whole thing square. How have you written what we have in bracket? Okay. So if x equals to 3 is a solution, that means x minus 3 equals to 0, correct? And if x equals to 2 is a solution, that means x minus 2 is also equal to 0. And we can multiply these two to go back to the quadratic equation. Here also I've done the same thing. We take this complex root across the equals to sign, and we take this complex root across the equals to sign, then this is what we get. This is like a step back. Okay? Make sense? Wouldn't it be x plus 2? That is correct. It would be x. That is correct. Oh yeah, I was wondering, a minus b mein kuch gadbad hai. Yeah, you're right. It would be x plus 2. So it is, you're right, x plus 2 minus iota into x plus 2 plus iota. Thank you for pointing that out. Now, this then becomes A and this becomes B. So that's A minus B. And this becomes A and this becomes B. So it's A plus B, A minus B. That means this is going to be A plus B, A minus B will be equal to A square minus B square. So x plus 2 whole squared minus iota squared. Now notice what happens. X square plus 4x plus 4 minus minus 1. So x square plus 4x plus 5 is what we end up with. Okay, and this is the exact same quadratic equation which we solved, and this is the exact same quadratic equation that we end up with again. Okay, now take a good look at it. Let me know if you have any questions. And in the meantime, I will do method 2. Okay, method 2 also works this, in method 2 also you have to use the formula. So it's going to be x square, okay, minus the sum of roots, which means minus 2 plus iota plus minus 2 minus iota. So that's the sum of roots into x plus the product of roots, which means minus 2 plus iota into minus 2 minus iota. Can 2 minus iota become b? No. because it's 2 minus iota and 2 plus iota. That's not possible. Okay, अगर ये दोनों same होते और ये होता x plus 2 minus iota and x minus 2 minus iota, then that would be possible. But the way it is right now, it's not possible. Okay. Now, let's simplify this, see what happens. So we have x squared plus iota minus iota cancels. Minus minus becomes plus, so this becomes minus 4. And then eventually once it gets multiplied by minus outside, it becomes plus 4x. Now let's see what's going on over here. So here also I can use the identity a plus b, a minus b, which means it's going to be a squared plus b squared. Okay, what's that? That's because it's iota squared equals to 0. So this is going to be x squared plus 4x minus 2 squared is 4. 4 plus 1 is 5. So plus 5 equals to 0. And once again, we end up with the exact same quadratic equation that we ended up with earlier as well. Okay, now we're not going to start a debate as to which method is easier. I'll leave it up to you, whichever method you want to use. But make sure you learn both the methods. Okay, now any questions? If yes, feel free to ask. If not, then let's do some example questions. There are 2 example questions that we're going to solve, some very lengthy ones. Actually, they're not lengthy, but there are 3 ways to solve them. So we're going to learn all 3 of them. And then as always, you can stick to one. So if you have any questions, please ask now.
Sir,
Yeah.
you said we can't take 2 minus iota as b. So how will we know that what can we take as b?
Okay. Look for 2 terms with a minus sign in between. Okay. So for example, we have x plus 2 in both the expressions.
Yes.
Correct? Okay. So that's one term. We can call that a. We have iota in both the expressions.
Yes.
Correct? We have minus in one and plus in the other.
Yes.
There you go. So we have a minus b into a plus b. The only difference is that a is not a single term. It's actually made up of 2 terms. And they are x plus 2.
So
That's
what
how we
if
know.
we had minus iota in both?
Then तो वो square हो जाता. It would have been the whole thing square. Then we can't use the
Oh,
identity.
yes, yes.
Okay. It's just
Okay.
that if you see the identity being applied, then go ahead, save some time. If you don't, then there's always the normal way, the regular way
Okay.
of expanding. ठीक है, इसको भी अगर मैं चाहूँ तो I can do it the normal way. I can do x into x, that's x square plus 2x plus x iota plus 2x plus 4 plus 2 iota minus x iota minus 2 iota minus iota square. I'll still get the same answer. Okay. Now, here's a past paper question. We're going to solve this and let's see what this question says. So it says it is given that u is a root of the equation. Okay. And where the constants a and b are real, find the values of a and b. Okay. So let's see how we can find out the value of a and the value of b. So first of all, let's plug in u. Okay. So this is method number 1. This is method 1, which is substitution. So we know that one root is 2 minus iota. Achha, if one root is 2 minus iota, then what about the other root? The other root would be 2 plus iota for sure. Okay, if you have one complex root, then there must be other complex root. And the only difference would be that the sign in between will be the opposite. So here's method 1. We know that a root is 2 minus iota. So what we're going to do is we're going to plug this in into the equation. So we have 2 minus iota cubed plus a into 2 minus iota squared minus 3 into 2 minus iota plus b equals to 0. Now, this is not just substitution. This is substitution. And we do something else, which is that we compare. Acha, अब be ready for some insane amount of algebra. Okay. So a good idea would be to memorize these 3 identities. That if you have a plus b, the whole thing cube, it's going to be a cube plus 3 a square b plus 3 ab square plus b cube. Okay, this is an identity as it is with every other identity that if you don't know it, that's fine. It's not the end of the world. You can do it manually. You can first you can first square the whole thing and then you can multiply it by 2 minus iota. It's up to you really how you want to do it. Okay, and if you want to go, if you want to take this route where you memorize the identity, then make sure that you also have memorized a minus b cubed, which is going to be the same as above, except that the signs would be alternating. A cube minus 3a square b plus 3a b square minus b cube. Okay. Now, 2 minus iota the whole thing cubed. Let's expand this. So this would be 2 cubed, which is 8 minus 3, okay, into a square, which means into 2 squared times iota, plus 3 into a into b squared, which means iota squared, minus iota cubed. Okay, minus iota cubed. Okay. Then let's expand 2 minus iota, the whole thing square. So that's going to be 4 minus 4 iota plus iota squared minus 6 plus 3 iota plus b equals to 0. Okay. So I hope you guys are with me. Now, like I said, get ready for some insane amount of algebra. 8, 3 square is, 2 square is 4. 4 times 3 is 12. So that's minus 12 iota. Okay. Now, 3 into 2 is 6. Iota square is minus 1. So that's minus 6. Now, what's iota cubed? Let's see if you guys remember. What is iota cubed? Yaad hai kisi ko? Let's go back. Remember, minus iota. That's correct. Okay, in case you've forgotten, you can always refer to the notes. Although make sure that you have it memorized eventually. So iota cubed is the same as minus iota. So we have one minus sign from the expansion and one minus sign of what iota cubed is equal to. So this will be equal to minus iota. Okay, then plus 4a minus 4a iota. Now iota square is minus 1, which when gets multiplied by a becomes minus a. Everything else as it is, minus 6 plus 3 iota plus b equals to 0. Okay. Now, then it eventually starts to simplify. So, for example, 8 minus 6 minus 6. So 8 minus 6 is 2. 2 minus 6 is minus 4. So let's write that down. So the constant is minus 4. Now let's simplify all the terms with iota in them. So we have, let's see what do we have. We have minus 12 plus 3. Anything else? And minus minus, which becomes plus 1. In fact, let's change it and write it as positive iota already. So minus minus iota becomes plus iota. Okay. Okay. So minus 12 plus 3, that's minus 9. Minus 9 plus 1 is minus 8 iota. So whatever terms that you've dealt with, cross it out. Okay. Now what we're left with are simply the unknowns. So we're left with 4a minus a. Isko bhi simplify kar lete hain, chalo, while we're at it. 4a minus a, that's 3a. So I'm trying to color code it to make it easy for you guys. Now we are left with 4ai plus b. Let's double check. Yeah, minus 4ai plus b. So let's write that down. Minus 4ai, as you write them, cross them, so you don't end up dealing with them again equals to 0. Okay, now remember, this method is substitution and compare. So we're going to keep a's and b's on one side and everything else, all the knowns, we're going to send across the equals to sign. So that means we have b or 3a plus b. Okay, so these are your real elements. Minus 4ai, this is your complex element, is equals to 4 plus 8i. Now, if you guys remember, how do we solve? What do we do when we're in a situation like this? We compare. So we've done the substitution part. Now what we're doing is we're doing the comparing part. So the real element compared with the real element, so that's 3a plus b, which is equal to 4. The complex element compared with the complex element, which is minus 4a is equals to 8, or you can say coefficient of iota with iota. So we have the value of a, which is minus 2, which we're going to plug it in here. So 3 into minus 2 is minus 6 plus b, which is equal to 4. B is equals to minus 4, 4 plus 6, which is equal to 10. So we have b and we have a. And let's see what the question wanted. Yeah, the question wanted us to find out the values of A and B, which we have. Now, as always, take a good look at it. Let me know if you have any questions. Okay, great. Now here's method 2. Method 2 is also comparing, but in method 2, what we're doing is we're using roots to go back to the original cubic equation. So here is method 2. What are we doing in method 2? We're going to be using roots, and then we will be comparing. Now we know that one root is, as we saw, that one root is -2 plus iota. We know that the other root would be -2 minus iota. And what about the third root? Do we know what the third, this is a cubic equation, right? Do we know what the third root is? Yes or no? We don't know what the third root is, okay? So we're gonna call it, because it's a cubic equation, it's possible that there is a third root. So the third root, since we don't know what it is, we're just gonna call it P. You can call it P, Q, R, just make sure you don't end up calling it A, B, because we've already used that. So just call it anything else, P, Q, R, whatever it is that you wish to call it. Okay. So that means if I wish to go back to the cubic equation, this is what I will have to do. I'll have to do x plus 2 minus iota into x plus 2 plus iota into x minus b. And this will take me back to the cubic equation, which is x cubed plus ax square minus 3x plus b. Okay, this will take me back to this cubic equation. Now, what do? We expand. Okay, what do we expand? We expand the left-hand side, since there's nothing that we can do on the right-hand side. So if you think about it, once again, I can use the identity where we have x plus 2 into minus iota and x plus 2 into plus iota. Now we already know the expansion of this. This is a coincidence because we've done it in the past. I think we had the exact same two roots. So I'm just going to write it directly because the working is the same. So we'll end up saving some time that way. So this will be x squared minus 4x plus 5 into x minus b. Okay. And once again, it's identical to x cubed plus ax squared minus 3x plus b. Okay. Now we start expanding. So as we expand, this is x squared, sorry. So x squared into x, that's x cubed, minus x squared into p, so that's going to be px squared, minus 4x squared plus 5x minus 5p. Okay. Yeah, x squared. I've fixed it now. And once again, remember that it's identical to this. Now what do? We compare. But before we compare, we write it nicely. We have x cubed. Let's take x squared common, since we have two terms with x squared in them. So if I take x squared common, so we have minus p minus 4 inside the bracket, then x squared. Then we have, I think we have just, so wait, I've got one term, which is minus 4px. So it's going to be minus 4x squared minus 4px in between. Okay, then we have 5 minus 4p, which is the coefficient of x. Let me make sure of that. Yeah, we have 5 minus 4p. Sorry, plus 4px, plus 4px. 5 plus 4p, which is the coefficient of x, minus 5p, which is once again identical to this. Okay, what do we do now? This is the point where we compare. So let's see what it is that's worth comparing. Okay, so what's worth comparing is the coefficient of x, 5 plus 4p, which is equal to what? Which is equal to minus 3. So 5 plus 4p, which is equal to minus 3. So 4p is equal to minus 3 minus 5, that's minus 8, which means p is equals to minus 2. Now, using this value of p, we're going to find out everything else. And what's that? The constant on the left-hand side is equal to b. Remember, we are supposed to find out the value of a and b. So minus 5p is equals to b, which means minus 5 into minus 2 is equals to b. And b is equals to what? B is equals to 10. And last but not the least, we also want the value of a, which is equal to minus p minus 4. So minus p minus 4 is equals to a, which means minus 2 minus 4 is equals to a. So 2 minus 4, that's going to be minus 2. So here's the value of a, same as the one that we got before. And here's the value of b, once again, same as the one that we got earlier. Now, as always, take a good look at it. Let me know if you have any questions. Now, what if I told you guys that there's a third method as well? Can you guess what that is? The third method? Any idea? Take a guess. Okay, nobody wants to take a guess. It's something that we use in cubic equations as well. It's something that we use in cubic equations as well. How many ways do we solve a cubic equation? One is through identities. The other is through one very common method. First, finding quadratic equation through first root. We can't do that over here. We can't do that over here because we can't find out the first root since we don't know the entire cubic equation. Okay, that's the reason why we can't do that. Since we don't know what the entire cubic equation is, we can't find out the first root through trial and error. Okay, so here's method 3. Method 3 is long division. Okay, now I'm not in favor of this method, at least not in a scenario like this. Why? Because we have way too many unknowns. Okay, but let's learn it anyway. It's important that we learn it, and then, like I said, you guys can stick to whatever method it is that you like, because in some cases we might actually have to use long division. Okay, like the example question that I will solve after this one. So we already have the quadratic equation. Okay, we already have the quadratic equation that's formed. And what's that? That's right here, x squared minus 4x plus 5. Now we know that if I divide x squared minus 4x, if I divide the cubic equation by x squared minus 4x plus 5, we will get a certain quotient and the remainder will be equal to 0. Okay, we'll get a certain quotient and the remainder will be equal to 0. So this is the equation that we are dividing, okay, with the cubic equation. Now, it gets a little bit technical because normally we do long division when we know all the terms. Here, since we don't, it might get a little bit technical, but bear with me. It's a method, it's a legitimate method, so we must learn it. Basic, if you guys don't want to use it, that's perfectly all right. So what should I multiply the quadratic equation with? I should multiply it by x. That gives me x cubed minus 4x squared plus 5x. Okay, and what do we do at this point? We subtract. So when you subtract x cubes, it gets eliminated. A x squared minus 4 becomes ax squared plus 4x squared. Everything else as it is, meaning that minus 3x minus 5x becomes minus 8x and plus b as it is. Okay. Now notice that the coefficient of x squared, okay, notice that the coefficient of x squared is actually a plus 4. Okay, this is where it gets a little bit technical. It's a plus 4. Now, whenever we're doing long division, what do? We try and make sure that the coefficient is the same so that we multiply it with a certain term so that the coefficient becomes exactly the same so that upon subtracting, it gets eliminated. So that means now what I have to do is I have to multiply x squared with a plus 4. Okay, I have to multiply this entire expression with a plus 4 so that we get a plus 4x squared. And now we have to multiply minus 4x and 5 as well. So minus 4 when we multiply it by minus 4x when we multiply it by a becomes minus 4ax. And then we have minus 16x and then 5a plus 20. Okay, so here's what we're doing. I'll walk you guys through the steps. X squared into a becomes ax squared. X squared into 4 becomes 4x squared. I've written it like this directly. Then minus 4x into a becomes minus 4ax. Then minus 4x into 4 becomes minus 16x. Then 5 into a becomes 5a. Then 5 into 4 becomes 20. Okay. So bear with me. We're almost there. Now what do? We subtract. Okay. Upon subtracting, x squared gets eliminated. Now we have minus 8x plus 4ax plus 16x minus 5a minus 20. Now simplify this a little. So this will give you 4ax plus 8x minus 5a minus 20. Now remember, what did we just divide it with? We divided it with a root. So that means the remainder must be equal to 0. Okay, this is the remainder. This must be equal to 0. Why? Because we didn't just divide it with some random expression. We divided it by a root. We divided it by its factor. So if this is equal to 0, that means once again, we will now compare. Okay, we will compare the coefficients. So we have 4ax plus 8x minus 5a minus 20 equals to 0. So that means the coefficient of x must also be equal to 0 and the constant must also be equal to 0. So what's the coefficient of x? That's 4a plus 8. And what's the constant? That's minus 5a minus 20, which plus b also. I think I forgot the plus b. Yes, plus b from before. Thank you for pointing that out. Plus b, plus b. Okay, now, so coefficient of x is equal to 0. 4a plus 8 equals to 0. That gives us the value of a, which is minus 2. Then minus 5a minus 20 plus b equals to 0. If I use the value of a, minus 5 into minus 2, that's 10. Minus 20 is plus b equals to 0, which means that b is equals to 10. So once again, we have gotten the exact same value. Now, the reason why I've done these many methods is not to confuse you guys, is so that you guys have multiple, what should I say, multiple tricks up your sleeve. The method that's easiest, every method has its pros and cons, by the way. Okay, substitution and compare means that you have to do a lot of algebra. In using roots and comparing, in this also, you have to do a lot of comparison. You have to do a lot of taking common and stuff like that. And method 3 is not something that I don't recommend. So if I were to rank the methods, here's what I would do. I would rank this to be number 1. Okay, I would rank this to be number 2 for this particular question, and this to be number 3. Okay, now there's one last question which we're going to solve. We have time, and then that would be the end of it, because I don't want to leave any of these concepts for the next class. So it's best that we do it today only. So here we are, unrelated, but never got any worksheets for numerical solutions. Yeah, you're right. We didn't get any worksheets for numerical solutions. I will, inshallah, compile it this weekend and then share it with you guys. Okay. Because the thing is, we haven't fully done all the concepts. We did very basic, so we were not in a position to solve any worksheet. But after today's class, you'll get it. Acha, wait, you're talking about numerical solutions. Okay, I thought you were talking about complex numbers. Okay, let me make a note of that. That's strange. You should have gotten worksheets for numerical solutions. Thank you for pointing that out. Let me make a note of that. Numerical solutions. Okay, thank you. Now, the complex number 1 plus 2 iota is denoted by u. The polynomial, now notice we don't have a cubic equation. We actually have a power 4 equation, a 4th degree polynomial. Showing your working, verify that u is a root of p of x equals to 0. Write down a second complex root. Okay, so once again, we have a lot of working. Make sure that whenever you guys have your P3 exam, you're well slept. Okay, because it's mentally quite draining. Now, first part, have you guys, I hope you guys don't have any other exam with P3. We need to verify that P of u is a root of P of x equals to 0. So that means we plug it in. Okay, we plug it in. That's the only way to verify whether it's a root or not. 1 plus 2 iota power 4 plus 1 plus 2 iota, root 2 iota, sorry. Root 2 iota squared plus 2 into 1 plus root 2 iota plus 6. Now, upon simplifying this, we should get 0. Now, let's see what the deal here is. Now, how do I expand 1 plus root 2 iota, the whole thing power 4? The answer is that I don't. Okay, instead what I do is I do 1 plus root 2 iota squared into 1 plus root 2 iota squared. Okay, and let's actually expand what 1 plus root 2 iota is in this step. So we have 1 plus 2 root 2 iota plus root 2 iota squared plus 2 plus 2 root 2 iota plus 6. Okay, and what is root 2 iota squared going to be equal to? That's going to be equal to 2 iota squared, which means it's equal to minus 2. P3 and Chem P5. Chem P5 is practical? No, wait, that's P3. Okay, I hope it's not the main theory paper. I hope. Now 1 plus root 2 iota, the whole thing square becomes 1 minus 2, which means minus 1 plus 2 root 2 iota plus 2 as it is. Sorry, plus 2 plus 6. So that's going to be 8 plus 2 root 2 iota. Now, we know that 1 plus root 2 iota, the whole thing square, gives us what? It gives us this. This is what it gives us. Okay, so now what we're going to do is we're going to expand minus 1 plus root 2 iota, the whole thing square. Okay, so I repeat, the expansion of 1 is equal to this. So the expansion of this will also be the same. So instead, we're just squaring the whole thing. So minus 1 plus root 2 iota. Now, I would suggest that working like this, well, you do on the side. Okay, so that the actual solution doesn't get messed up. Okay, do it clearly so that the examiner can see it, but do it on the side. So this is going to be a square, which means minus 1 squared, minus 2ab, which means it's going to be minus 2 root 2 iota, plus root 2 iota squared. Now, we already saw what root 2 iota square is equal to. So this will give us, this, so wait a minute, this is 2 root 2 iota. Okay, sorry, my bad. Let's do this again. So minus 1 plus 2 root 2 iota, the whole thing square. So this becomes 1 plus 4 root 2 iota plus 2 under root 2 iota, the whole thing square. Okay. So 2 root 2 iota becomes 4 times 2. So that's going to be 8, and iota square will be minus 1. So that's minus 8. So 1 minus 8 becomes minus 7. Minus 7 plus 4 under root 2 iota. So we have minus 4 plus minus 7 plus 4 under root 2 iota. Okay, and then we have minus 1. Okay, let's make sure that we don't end up making a sign error or something. Minus 1 plus 2 root 2 iota. And then, so wait a minute, this is going to be minus, yeah. So we've dealt with this plus 8 plus 2 root 2 iota. Okay, now if we've done it correctly, everything should simplify to 0. So 2 root 2 iota plus 2 root 2 iota, that's 4 root 2 iota minus 4 root 2 iota, that simplifies to 0. Minus 8 plus 8 is equal to 0. So 0 equals to 0. Therefore, we have shown that it is a root. And what's the other root going to be? If one root is u, which is 1 plus root 2 iota, then the other root would be the conjugate of u, which is equal to 1 minus root 2 iota. Okay. Acha, up part 2. Part 2 is that find the other two roots of the equation, p of x equals to 0. So we've already found out two roots. Let's use these two roots to go back to the 4th degree polynomial. So this is one root, which instead of using u, let's use x. Okay, so x minus 1 minus root 2 iota, and the other would be x minus 1 plus root 2 iota. Okay, So let's find out the combined quadratic equation, which we get after multiplying the two roots. So once again, x minus 1 can be treated as a and root 2 iota can be treated as b. So we have a square minus b square, which is going to be a plus b a minus b, which is going to be a square minus b square. So x minus 1, the whole thing square, minus root 2 iota, the whole thing square. So this becomes x square minus 2x plus 1. Root 2 iota, the whole thing square we just saw is minus 2. So minus 2, which means x square minus 2x plus 3 is the cubic equation that we get. Yes, Fatma.
Sir, in the question above, why have you written it minus 1 plus 2 root 2 iota? Like minus 1, wasn't it plus 1?
इसकी बात करें आप?
Second step.
This one?
First question, second step.
अच्छा, first question, second step. First question. इसकी?
Part 1. जी, इसमें minus 1 आपने लिख दिया है.
देखो, मैंने बताया ना कि जब हमने 1 plus root 2 iota को expand किया, so after expanding it, this is what we got. देखो,
ये हमने डायरेक्टली वहां पे भी इसी तरह करना है.
यहाँ पे भी हाँ, so it's the same thing, no? So see, here we have 1 plus root 2 iota, the whole thing power 4. Here we have 1 plus root 2 iota, the whole thing square. So we break this down into this. Now we have to expand what 1 plus root 2 iota is, right? So the expansion of 1 plus root 2 iota, the whole thing square, we've done it here. And this is what it simplifies to. So that's why, think of it this way, that we replace the expansion with minus 1 plus root 2 iota. Okay, now that's what we're squaring.
Okay.
Okay. All right. Now we have the final, we have the quadratic equation. Now to find out the remaining roots, we will divide the fourth degree polynomial with this quadratic equation. Now what's the fourth degree polynomial? It's x power 4 plus x square plus 2x plus 6. So remember, the remainder must be equal to 0. If it's not equal to 0, that means we've done something wrong. So what do I multiply it with first? I multiply it by x square. So we have x power 4 minus 2x cube plus 3x square. Okay, let's be careful with the signs. So x power 4 minus x power 4 cancels. We have 2x cube. That's what we're going to write first. X square minus 3x square is going to be minus 2x square plus 2x as it is plus 6 as it is. Now, what should I multiply x square with in order to turn it into 2x cube? That's going to be 2x. So this becomes 2x cube minus 4x square plus 6x. Okay, we have to multiply all the terms. Now 2x cube minus 2x cube cancels. Minus 2x square minus minus 4x square becomes 2x square. 2x minus 6x becomes minus 4x plus 6 as it is. So what do I multiply x square with in order to turn it into 2x square? That's 2. And notice what happens when I do that. We have 2x square minus 4x plus 6. And upon subtracting, everything becomes 0. So all we have to do now is we have to further factorize this. X square plus 2x equals to 0. And when we do factorize this, we will get the remaining two roots, and they will also be complex because that's what the question says. Actually, the question doesn't say that whether it's complex or not, but we get complex roots. So that's going to be minus 1 plus iota. I've skipped a step here, or x equals to minus 1 minus iota. And how do we do this? We do this by using the quadratic formula, which is minus 2 plus minus square root of b square. So that's going to be 2 squared minus 4 into 1 into 2 divided by 2a. Okay, simplify this. This is what you will get. And there you go. That's the answer. Okay, so you guys can see how complex this chapter is. So there's a reason why it's called. How can we use calculator? You can use calculator and solve this directly in your calculator. Your calculator will give you the complex answer. So go to menu, go to equation. Here it is. Go to polynomial, second degree polynomial, 1, 2, and 2. There you go. Minus 1 plus iota, minus 1 minus iota.